Okay, so let's go ahead and get started. I am Dustin Popendick from National Institute of Science and Technology Standards and Testing. I should know this. I'm hosting, yeah, ISIAC and ISES webinar today. My role today will be to facilitate. What we're going to try and do today is have a guided discussion on the modular mechanistic framework that has been recently published for assessing human exposure and chemicals in materials and products. So I'd like to start out just with a quick poll, and hopefully everyone can see this. And we just want to get an idea of who our participants are and who we're talking to. So if you could take a moment here to fill out this poll, if everyone can see it. Can I get a nod of the participant or the panelists? You guys can
I can see it.
Okay, so
but
we'll give everybody a minute
Yeah,
here, and we'll start getting some results in really quickly. This is great. And while we're doing that, I would like to mention we have a couple conferences that are coming up. Within ISIAC, we have 2 Healthy Buildings conferences. One, Healthy Buildings Europe, will be online on June 21st to 23rd. Abstracts are due tomorrow, so please, please, please send in some abstracts. It'll be online, so anybody can participate. You don't have to travel. Go ahead and submit something from California, submit something from China. Anybody can participate. Same thing, we also have a Healthy Buildings America coming up in Honolulu on August 10th through 12th. That might also be in person and online. And then finally, there will be an ISES virtual conference end of August, early September. So keep your eyes out for those. All right, so we have 80% people have finished the poll. So let's go ahead and see where we are. So can everybody see these results?
Yeah.
Great. So panelists, this is your task. Now you know where we're coming from, where people are backgrounds are. It looks like we have a lot of people who are interested in the topic, new to the topic. I would say myself, I'm not an expert. I'm somewhere in the moderate range. And a lot of people who are interested in the topic and haven't actually used or developed these models, but we do have some experts here. So be careful what you guys say on the panel. All right. So I just wanted to start off with, we approach this topic, SVC modeling, and I think before we even get into it, I want to make sure that everyone is on the same page. Oops, wrong way. And be aware that there are multiple definitions for what an SVOC is. This is from the ASTM standard D81, I have it mislabeled on the slides, D8141. And just, there are a variety of different ways you can define what an SVOC is based on the vapor pressure, boiling point, retention times. And there's a wide variety of people's definitions on what an SVOC is, whether it's from ISO standards, ASTM standards, WHO, Charlie Weschler, John Little, we all have different standards. So let's just be aware that, we're talking about some class of chemicals. But when we think about this framework, be aware that this framework doesn't have to be limited to SVOCs. It was just developed from the SVOC approach. We can also model VOCs. So at this point, I'd like to turn this over to Dr. John Little from Virginia Tech, and he'll give us a background of where this effort originated from. So John?
Okay, and at this point, is it possible for Clara to show her slide?
Working on it.
So I'm only going to say a very few things, and that's the slide that I'm hoping to use. So what I wanted to say is that for me, this story started almost exactly 30 years ago. So when I started doing my postdoc at LBL, and so that's about half my life. And well, initially there was like a few of us and we hardly knew each other, and we were working on VOCs initially. And then later we moved to SVOCs. And initially it was sort of like a competition. And the competition was sort of who could identify, you know, the mechanisms that were controlling the release of VOCs and SVOCs, and who could identify mechanisms to understand exposure. And then sort of slowly over time, we started to meet up at conferences. And then, for example, I went to Beijing in 2003 and I met with Inping Zhang then. And so slowly we sort of started to become friends. And we were no longer really kind of competing, but we were sort of cooperating. And as the years kind of went by, so we sort of slowly became more and more friendly and developed a bigger and bigger circle until eventually we now have what could be called a community. And in a way now, you know, maybe like many of the great challenges in science right now, the problem is not so much going to be resolved by competition, who can, you know, propose the best framework to, you know, the problem is how to implement what we know. And so it was, you know, given that we had this this nice community and we were all more or less friends, it was relatively easy to create this consensus. And what we want to do now is implement it. And that's why we're having this this webinar. So so thanks, Dustin, and I'll hand over to Clara.
All right, thanks, John. Let's see if we get this started. Yes, as Dustin said so nicely, we're here to discuss basically, but to say a few more words about the framework and where we are coming from, I'm going to give a brief introduction to the whole idea. And thanks to Dustin and John, we all have already a little bit of an idea what's it about, but maybe this helps a little bit more as well. So it's all about the question, what are we exposed to indoors? What chemicals are we surrounded with, at what concentrations? And we care about this because some of those chemicals are actually not good for us. I mean, chemicals are, of course, everywhere, but some of them might be harmful. And people spend most of their time indoors, and we need to better understand what we are surrounded with. So we were, or many of us were wondering, how can we assess exposure to chemicals indoors? And the problem is that we can, of course, not measure everything. It's basically impossible. So what we do is usually go back to modeling, and we model emission and transport of chemicals indoors, and based from that, we can estimate exposures. These exposure estimates are averages. They won't apply to all situations in all cases, but at least they give us a pretty good idea of what's out there. At least that's the idea. And there are a lot of approaches, especially for SVOCs, how these exposure estimates could be derived. And the research has been going on for more than 15 years on SVOCs by now, and on VOCs for even longer. And so we were wondering a few years back, is it possible to look at all of those models and achieve a consensus regarding the most appropriate way to estimate exposure to indoor chemicals? Because a lot of these models had a similar starting point, but then diverged in like small aspects or sometimes larger aspects. But yeah, there's a potential for a consensus. And that led to the work we're talking about now. And actually, a little over a year ago, there was already an ISIAC webinar where we introduced this so-called consensus framework. As Dustin said, we focused this original framework on SVOCs because that's what we know best. Back then, we described also the consensus process, how we got together with international scientists of the field and discussed how we could make this work. And after the webinar, we got a lot of input, we got a lot of interest from people, and also we needed to do a lot of revising because we got so many good ideas to work with. So it was another year before we finally had our publication out there. What John just talked about, 26 international co-authors, and then more than 40 signatories who expressed interest in the framework. And I hope many of those are actually here today. So we have some momentum here. We want to use that. And that's what this discussion today is about. But before we dive into this discussion, I want to briefly go over the framework itself, just to also bring up a little bit of terminology maybe that might be interesting and good to know. So in the framework, we have so-called source emission categories, SECs, which have been derived from a continuum of possible sources, because some sources, there's overlap between categories, but we have to start somewhere. And the idea was there to start with the product, with the source of chemical emission. Then we have the indoor environmental compartments that we use to describe mainly partitioning among those compartments. And we describe what's happening indoors using mechanistic models. For one thing, to describe the behavior of chemicals indoors, but also hopefully to estimate exposure. And these resulting exposure estimates that you get when applying the framework approach, and if you combine those estimates with external toxicity data, you get a risk estimate, and you can use that for prioritization and risk ranking of products or sources. So the good thing about mechanistic models is that they are very universal. They rely on physical processes, and they have several benefits, like they're generalizable. They can be varied in their level of complexity based on different assumptions and a few other things, but they are not always available. So sometimes there are statistical approaches that we could use, or empirical models, or even just expert opinions when, if nothing else is out there. So as I said before, we have these source emission categories, and I'm showing them here for the SVOC example. In this case, we have 6 of them that are all mechanistically consistent in terms of how they emit substance, an SVOC. So it doesn't really matter what the SVOC is, as its behavior in the source should be the same. From there, we have emission into an indoor environment. And as I said, we describe these indoor environments based on compartments. And then there are several assumptions that go into the models that then are used to describe the behavior there. And I'm not going into the details here. That would take a bit too long, but just be aware that we have to make assumptions for these models. Otherwise, we have to constrain the models to make them work. And then, of course, we have exposure pathways. And here we differentiate between contact exposure and mediated exposure. And I know some of you are probably more familiar with the terms direct and indirect exposure, but these have been defined so differently in different contexts that we chose to use the different terminology here. So contact exposure is everything where you interact with a source directly and get exposed that way. And then we have mediated exposure, where the source emits into the indoor environment, and then you get exposed from that indoor environment. This is the basic idea here. And then we put the pieces together and we get something like this, where all these arrows basically stand for models, for modeling equations. And as I said, in the best case, we have mechanistic models to describe those relationships. Often we don't, and that is where definitively more work has to be done. And then there are some other aspects and factors that we need to consider that are influencing the complexity of these modeling efforts. For example, what about occupants and their influence on indoor chemistry or the indoor environment in general? What about indoor chemistry altogether? Then there are aspects of uncertainty of modeling parameters, lack of measured data to compare the results with, and so on. So there are a lot of unknowns still that need to be addressed. But the idea is that this modular structure of the framework allows a step-by-step improvement in the future. So I think it became very clear this is work in progress. So we intend this framework as a roadmap for future research, and also to serve maybe, and that's what we're here to talk about, as a basis for a more general indoor exposure community model. As Dustin said before, we worked with SVOCs here, but the idea is that it's modular and can be adapted for other chemicals and other chemical groups. And the key question is really, how can we make it better in terms of accuracy, robustness, and so on? So we have collected a few open questions that we want to address today. And we will come back to this slide a few times, I'm sure. And I encourage everyone on the call here in the webinar to add their questions if they can think of something that we haven't thought about at all, and they think that that might be important. So with that, thank you. And now we will get some input from Charles Babington from CPSC. And I hope Elaine has joined the call by now as well. So I hope everyone will join the discussion, and thank you.
Thank you, Clara. Can you see my screen now?
Yes.
Okay, great. So I'm going to say a little bit more before we let Charles speak. Definitely want to hear his perspective. But so we put forth this effort with a lot of people to come up with this great framework where each one of these arrows represents a bunch of different equations and assumptions. But I wanted to emphasize, as John was saying, this is something that he's been doing since he was a little kid. And you know, we have a lot of this that we've done for a while. This isn't our first rodeo on trying to model SVOCs in the indoor environment. We've been, as I say here, we've been on this bus for a long time. If you go back all the way to 2004, Bennett et al. Came up with one of the first published mass transfer SVOC models. And I'm going to roll through a bunch of them here, so I'm not going to spend a lot of time on them. Our own panelist here, Ing, started her dissertation with this model, looking at phthalates. And then we moved on, and Charlie Weschler and Bill Nazaroff introduced the first stick figure into these models, which was a big theoretical improvement of actually putting stick figures in these models. Then John said, I can up you one and I can make my stick figure a little bit more round. And still, again, if you'll notice, though, that the framework, that these models are pretty much making the same assumptions when we start looking at all the things they're taking into account. She et al. Actually put a human silhouette in, so our models have expanded. But again, the basis here is the same. We've got, and you know, I think they added some possible sources from activities in here. The US EPA, again, all of these models, I call them conceptual, meaning, you know, each individual research group came up with their set of equations, solved their set of equations, but there was nothing you could go out and acquire from the web and plug in your own equations. And then in about 2017, we started coming up with what are more like conceptual models, and Charles can describe these in more detail, but they take more of the framework of, you know, thinking about where different sources and sinks are coming from. Wenjun Wei and one of our panelists, Corinne, came up with another model in 2019. Come on, there we go. Whoops. And then we started looking at the color pink and looking at, you know, more closely into specific sources and sinks, and how when we start looking at those sources and sinks, they might be different if we have a solid surface versus a softer surface. In 2020, we were introduced to the best artwork I've seen, with including the Toronto skyline in their graphical abstract. And now 2018, we started getting into models that actually have been coded and people can share these models. The Lee et al. Group started this in 2018. There's also I believe this is an EPA model, and Charles can, and Elaine can correct me, that is more of a conceptual framework model that takes into things account like habits and uses and how often people are using things. There's a DustX model that's also within EPA. They regressed a little bit back to stick figures, but again, taking in human activities. And then there's a consumer exposure model, also by EPA. This one, again, not only has a code, but has a graphical user interface. So it's not just lines of text that we're trying to deal with. So it's a little bit more user friendly. And this is available on the web. And then finally, the one that I'm familiar with is the indoor concentrations and conditioned and unconditioned zone model, also produced by EPA and released in 2019. All of these models are great. They all have pros and they all have cons. What we're trying to do here is trying to incorporate something that's a little bit more dynamic and flexible than all of these models. So what are our next steps? Well, it's complicated. If you think about all the different things that have to go into a modeling of an indoor environment, you can go on for ages. I mean, we can just have a discussion that'll go on for months and we start thinking about everything we need to take into account. So that's where, John and Clara came up with this framework, is trying to think about what is the best way that we can actually go forward and produce something that's useful and actionable, something that regulatory agencies can look and push lead on, or researchers can also use to make new conclusions. And so what the big picture here that we're trying to think about is, can we do some kind of future where we have an open source code model that everybody can contribute to, has a graphical user interface. It has components that you could plug in as you need them. So if you're interested in hard items, you can use those components. If you're looking at soft items, you can look at those components. And we can use it without it being fully developed. We don't have to have every single pathway done before we can start using it. And users can decide which pathways they want to be interested in. And the key here is that it's open source, that everybody can contribute to, everybody can validate, and it can be a community tool. And it will expand and take into different accounts that we need to think about. And there's precedences for this. Hopefully I can switch to this. These are some of the community sourced programs that other environmental groups have looked at. And so for instance, can you still see this? Okay, thank you. So there's this residential population generation, parameterized residential. You can read it, but it's basically the same type of thing I'm talking about here. There's the collaborative reverse outcome pathway group that has a graphical way that you can start looking at all of these different problems. And one of our panelists here is much more versed in all of this. I'm just saying that there are these open source communities that look at specific problems and have come up with solutions that we can use as a model to start looking at how we can address making this a useful item. Oops. So I'd like to introduce two of our panelists to give us a little bit of a government perspective before we open this up to our full panel. The first one is Charles Bevington. He's at the United States Consumer Product Safety Commission and has been dealing with SVOCs and modeling of SVOCs for a number of years. So I'll let Charles talk for a couple minutes and then we will move on to Elaine. Thank you, Charles.
Hi, my name is Charles Bevington, and like Dustin said, I work for the Consumer Product Safety Commission, and there's a large number of people on this webinar and a large number of agencies represented that are operating under different statutes, different regs, and may have a different question that they're trying to answer with their modeling. So the first point that I want to make in these couple of minutes here is that there's kind of a fit for purpose aspect to any modeling exercise, and that it has to be tailored to the question that is being asked for that specific statute or reg. Another thing to think about with modeling in a regulatory environment is kind of evaluating the results of that model and considering whether they're transparent and reproducible and representative of the scenario that you're considering, that they're accurate, and that they've been evaluated in some way. There is a recent OECD document that was cited in the consensus framework, and the title of it itself doesn't necessarily seem like it's related to consumer exposure modeling, but there is text towards the back end of that document that I think is helpful. So the name of it is the Internationally Harmonized Functional Product and Article Use Categories. And in addition to providing definitions of functional uses, product uses, and article uses, it talks about how those could be used in the context of consumer exposure models. Every country or every agency might have a slightly different word that they use for, a consumer product or an article or a building material. But the information is reported to those governments in what we hope will be organized around these OECD codes. So crosswalking those OECD codes to what the framework calls the source emission categories, I think will be a great next step. And the very last line in that document says exactly that. So crosswalking article codes and consumer product codes with those and existing consumer exposure models, and updating and harmonizing those exposure scenarios within those models over time. And I think that's very consistent with what's in the consensus framework. And I think that's all I wanted to say for now. So thank you for letting me talk for a couple minutes.
Okay, and our next panelist is Elaine Cohen-Hubble from United States Environmental Protection Agency. Give her perspective for a minute or two. Thank you.
Good morning. So I guess I always come with a little bit different perspective because I'm in science, the science side of EPA, Office of Research and Development, and not on the regulatory side. And I think what I've learned after years and years and years in this role or in this office is that as researchers, we have a lot to contribute in terms of building that scientific foundation that the regulators can draw on. When they're going to make their decisions, Charles made some very good points about that decision context being, really the driver for whatever it is somebody using a model is going to look for. And it's also why whatever, a research community puts out, the more there's a focus on getting those research pieces, scientific consensus and building out the capabilities, that scientific building in the science, having these capabilities so that given whatever new decision that comes up, regulators can draw from that research source. But also importantly for the research community, we've just found that, what we need to really, build, advance the science and be prepared when regulators ask us questions and need to draw on the science is fundamentally something very different than building a regulatory model. And I'm just going to put out there for this group that, really what you all bring to the table, what we all really can contribute and build and have been building, but maybe can do in a more accessible, open, and collaborative way is this capability, is to always be bringing the newest science in and making it really accessible and usable, in a whatever the latest, greatest way is. And so that's what some of the examples at the very end of the talk was sort of just saying there are groups now and different kinds of modeling tools that are being made available in a way that everybody in the research community can sort of pull on those things, use them, extend them, and then also make them accessible. And I think what's going to be really important about that is then we don't get, I think harmonization activities are important. I think making sure everybody's on the same page, understands what's available, what the science is, and how to use it is important. But I also hate for us to get bogged down year after year in some of those details, since they can be so decision driven, and really just enable the science, which, I think this framework and, and sort of these activities that John's been incubating are so exciting.
Okay, thank you, Elaine. We're going to move on to introducing some more people, talking heads. We have three great guests here. Ying Xu from Tsinghua University, who is our ISIAC president-elect. Corinne Madin from France, our current ISIAC president. And then just to get the historical perspective, we brought in Glenn Morrison and, our past ISIAC president. And so I'd like this panel and Charles and John and Clara and Elaine to try and just discuss some of these topics, and I'll leave this up. And let's start with the first two topics. I think the most important thing when we start talking about trying to build an open source model is who are we trying to build it for, and who should our target audience be, and how do we get all the relevant stakeholders engaged? So go ahead and let's go ahead and start this discussion. Whoever wants to jump in first, please do.
I'll tell you what, I'll jump in. I'd say that a good open source process actually is one that audiences will come to. Sure, there's going to be some target audiences, but I think Charles made a good point about this fit for purpose models, that everybody's going to have a different need, but fundamentally the science is the science. And the core of this kind of model, this open source model, will be the same regardless, right? It's just the science. It is the mechanism, it is the chemistry, it's the thermodynamics. And so getting that right, and then having the audiences help define the GUIs and the maybe the methods of inputting certain variables, that sort of thing, is great. So the specific target audiences, it should be set up in a way that it would benefit clearly identified ones like the EPA or CPSC, or the science, but also be generalizable to any audience that wants this kind of information.
So Dustin, I thought I would just say that I know that Elaine has, and maybe this is a more general idea, but Elaine has this idea to use scripts to sort of represent little pieces of a whole workflow, so that you can kind of put these scripts together in different ways and sort of answer different questions in almost in a sort of an automated way. But maybe Elaine, maybe you're the right person to describe that.
Sure, and again, I think Glenn's points about really providing the science and then that users will come is really important, and in many ways, I see the target audience as the researchers first, because right now, every time somebody is interested in doing one of these models, they start with their advisor's code. They start from scratch. They take something and build on it, but in a clunky kind of way. And if what we're trying to do as researchers is make these things available to the decision makers or to people who have a particular specific need for that, the more every time we work on a problem, we sort of make the data and the code modules available in a more common way and put those packages out and put them in a place where everybody can go and get the different pieces, the more, we sort of enable that. So people have been, are doing, this is not my idea, but, this whole idea of these computational workflows, where you have sort of the pieces that you can draw from, whether it be the data, the mechanistic models, the analysis piece, and even the visualization. And those things are commonly available. There's entire communities, built around our scripts and algorithms and things that you can go grab those things and use them without recoding, recreating, and reinventing things. So it's sort of taking a lot of those common steps and processes that other people are starting to put together in these workflows, so that then when somebody has a decision context, they don't necessarily have to recreate the data or the mechanistic pieces. They may just need to grab a different visualization tool, or overlay a different population or different set of building characteristics.
Yes, if I may add about target audiences, of course, there are the researchers. This is the first target, but I realize in Europe that the people doing risk assessments in public agencies or in public bodies doing regulation, they are really far from our tools. They don't know our tools. They don't know the modular framework. They don't know what exists. They are really disconnected, and they are really using very basic tools. So I think we really need to reach these people to develop the modular framework. And this is why we need accessible tools also to convince them to use. And right now in Europe, there is a new strategy coming in place for chemical management. So this is exactly the perfect opportunity for promoting this modular framework to push people to use it.
Okay, let's move on to the next set of questions, 3 through 5. This is a great concept, but it all gets down to time and money, which we all have troubles with. So, how should we develop the model? Is there any way that we should be looking for funding? Who should be responsible for maintaining the model? How do we get, is it housed within a government agency? Is it housed external? And where should it physically be? And what, maybe even get into what programming environment, we want to use.
You gave an example, Dustin, during your presentation. So how is it funded? You know?
Those were examples from Elaine. Elaine?
Yeah, so those are our own. I think the answer to a lot of this is going to be through whatever case examples and problems people are working on and being funded on, right? So there's on some level, I don't know, at least where I sit, that there's going to be some single funding source. And I could be wrong about that, because Europe, certainly has very different funding opportunities, and sometimes really wonderful ones that we do not. but I can't really speak to funding per se, except that as we any of us are working on problems that we are funded to work on, if we sort of have this common agreement or understanding that there's a repository available where we're all going to put these things. So we have what I showed you are examples of a couple different repositories where we're making our code available. I think the HTTK one is just a really nice example, because John Wamba has led that work. And basically every time they publish a new analysis, a new module, it gets published, and the package that they do our packages get put in the repository and made accessible. For us, at being scientists in a regulatory organization, it means that we can publish things that are research tools that other people can access simply by going through the publication clearance process without going through full-blown regulatory reviews, which are years and years of and aren't necessarily the point of having this science and these tools available. But they're just kind of GitHub repositories. Anybody can get to them. And so I think the question for a group like this would be, so not necessarily who would house the repository, but who would be the master that would say, yeah, we can send that one out as a part of this common framework that everybody can access. Is our doesn't even all have to be in one particular code, or doesn't all have to be in R or Python or whatever, but it would all be accessible. So we could build on what we're already doing at EPA with this GitHub, and talk about whether that's a possibility. But there's, that's sort of the model that has been working for us. And then again, how each piece is funded and who works on it is just really based on the particular problems. We're not really funded necessarily to create a model per se. We're funded to, answer particular chemical exposure and risk questions.
Yeah, I think Barbara Turpin asks a nice question here is, the nice thing about modular framework is nobody has to tackle the whole thing at once. But we have to agree, as she says, on a language or a handshake, the input output between the various modules and the naming conventions. And I think, that's something that we need to figure out, which way should we coalesce around this, and how do we form a group to come up with those initial hurdles, because that's really the barrier to starting this process is, everybody's on the same page on language. We name all the parameters the same. I mean, simple things like the air change rate. I've seen 5 different parameters used in the literature for what air change rate is, and just figuring out those basic things are some of the things we're gonna have to think about.
So may I ask a question along those lines? So to do that and to fund even like a workshop just to pull people together to do that, because I think that's absolutely the first steps. Is there does the group have a common, I still think that needs to be done around a case example. So right now I'm working a lot on PFAS chemicals. Is there something, because I might be able to help, if we could coalesce around, a particular problem again, and then say as part of that, as part of the work that we're doing on that problem, we want to initiate this, this connection.
That's a great idea, Elaine. And, I would just say that in a way, the example in the paper of, SVOCs coming out of like a flat flooring, if there is a kind of a PFAS example that fits that kind of source emission category, that would be the one to go with. Clara, do you agree? Because you're working on PFAS. Can you think of an example that fits that sort of source emission category that we could build on?
I agree that it would be great to have something like that. The diversity of the PFAS class makes it a little bit more difficult. So as it is the example with vinyl flooring and DHP for the phthalates as a subgroup of SVOCs, we may have to look at the PFAS in a similar way and actually then go a little further and say we have a subgroup of volatile PFAS, and there we have, I don't know, coating of a Gore-Tex jacket or something like that. So
I mean, couldn't you just use almost that same, source emission category for a particular PFAS, just one PFAS, not
you could
all
to
PFAS?
some extent. not all of them are equally relevant between SVOCs and PFAS, but you could. The solid category is certainly one that can be transferred to PFAS.
So then that would be like quite an easy example to start with anyway, and that example includes all these interactions with surfaces and air exchange and particles and, chemistry. And so all those things that we kind of need to think about, broadly as we develop the kind of the modules that are going to be plugged into this thing.
And the thing we will run, if we want to do it really in a quantitative way, the issue we will run into there really quickly is that we are lacking the parameters to really do anything meaningful in terms of getting any numbers. Because for PFAS in particular, we don't have the information we need to parameterize these models at all.
But for a workshop, wouldn't it be possible to have like one PFAS in one product and use that as the kind of PFAS example and, build out from there? Sort of like our,
I think this
vinyl flooring case. Sorry, Elaine.
Yeah, I mean, I don't want to kind of derail your discussion on the PFAS problem, because it can be complicated, but at the same time, I think this issue of having the perfect problem with the perfect set of parameters is not where it is a little bit limiting in terms of sort of setting something up and demonstrating potential for this kind of resource and capability, right? Because as researchers, that's what we do, is we start by, I hope that's the power of modeling, right? Is we start by trying to, defining or having a problem, right? So whatever set of products with whatever set of chemicals or whatever, and then really figuring out where we do or don't have parameters, and then going and getting parameters, right? So
Elaine,
you can be building out the mechanistic, the modeling framework and these pieces and the data set, because the data sets become key too, right? And so I don't feel like having the perfect problem should be the goal, because then it's done. Why do we need to spend research time?
I know what you mean, Elaine, but Clara, can you go back to your framework, the image of your framework?
I think Dustin, these were Dustin.
Okay. Oops, we just skipped over it. There we are. So there, the whole idea is that, you've got these 1, 2, 3, 4, 5, 6 sources, right? So they all behave a bit differently. But once they release their compounds in their kind of mechanistically consistent way, then after that, they are no longer sort of relevant to what's happening, in the indoor environment. And so then you've got these different compartments, and you've got interactions among the compartments, you've got people being exposed. So everything that happens to the right of those sources is sort of this modular, compartmentalized section of the framework. And within that section, you've got transport, you've got chemistry, you've got exposure, and all of that is the kind of thing that that was being, that Barb was mentioning. That's where we need to think through, like, the communication with other processes, and making the framework as general as possible. But in a way, it's not so dependent on the sources. Do you know what I mean? So in a way, just having one source as an example is quite useful, because many of the kind of the compartments and the transport mechanisms are engaged. Do you know what I mean? Does that make sense?
Yeah, no. My only point was that I don't think you have to pick one that we've already got all the parameters for, right? Like I think people are working on that, and maybe that's part of it, is figuring out who right now is doing experimental work to get at some of these parameters. Pick, like you said, so pick carpet or whatever you pick.
But
all I know is we probably shouldn't pick vinyl flooring again, John. They're
Yeah.
a little upset with you.
I understand, but
I think Miriam Diamond and Karsten Baumann both were pointing out that, PFAS, we don't have a lot of data right now, but there are a lot of people working on it, which would provide a platform to bring more people into the process. I know there's people at NIST, there's people at EPA, and then just the bunch of people who are actually working on it. And there are a lot of other different software or people who have done similar type of community source things that we can lean on and learn from. Several people have mentioned the NIST Fire Dynamic Simulator. Barbara also mentioned Megan and Bias for Outdoor Biogenic Commission. So there's a lot of different platforms we can look for inspiration.
I just wanted to
go ahead, Glenn.
I think Elaine's absolutely right that starting with a case, basically a case study, a question to allow to help organize how this is structured is important. But at the same time, it's easy to do that and find that you've created roadblocks to having it be flexible. So sort of alongside that process would be having other maybe a separate kind of workshop where you're having different stakeholders, et cetera, come in and say, is what you've produced for this case study sufficient to meet the needs of this researcher for this problem, and as many problems as you can define, to say, is this going to be sufficiently generalizable? That's my only point.
Okay, we have about 8 minutes left. I think there's a lot of places we can learn from. CFD modeling, Ender Ferraro mentioned, they use a commercial package, and everybody uses the same commercial package with user-defined functions. That might be one option to go, but I'm not sure regulatory agencies would want to be relying on that. One of the questions we had here is, as much as we've been spending time on coming up with this framework, there still will be debates on what is the best approach. There'll be new modeling solutions. There'll be new approaches to modeling different environments. And how do we decide how to incorporate those into different components of the model, and who gets to decide what should or shouldn't be involved in the package? Basically these questions 6 and 7.
I mean, I would just say the point that this, if we're doing this in the right way, nobody should have to decide. It should all be, you need a particular, so I wouldn't, this is not, I don't envision this, and I don't know about John as like one big package. I mean, the point is you have the different script packages or programming modules, whatever you want to call them, the modules available, and you could have the exact same piece of the system, and still somebody wants or needs or decides to develop another module describing that piece of the system because they have other information, they're focusing on a different mechanism that's more important for one particular compound than another compound. I mean, there's a whole host of reasons why people always do and always will need or want to do something differently. So I think the power of having sort of this kind of a framework or is just that then those pieces are available, and that whether or not they're available even in the exact same code. I mean, Barbara's point about the input output and being able to put things together in some kind of workflow where you can draw from one to the next is really the key thing. So I would just argue against over-prescribed and needing anybody to be, sort of the decision maker.
Yeah, I fully agree with that. So I guess the great thing about open source code is that it's in a way self-regulatory. So if people like it, if it makes sense, if it's transparent, if it gives you the output you are hoping to get in a good way, it's going to get used. And things that won't get used will either be forgotten or revised. That's at least the best case scenario. And where I see potential conflict, or where this question might be more important, is actually at the starting point level, just what we're talking about right now, like who feels responsible to do things, who says, okay, we're doing this in R, or we start doing it in R, or this is how we call the air change rate now. And where this question needs to be, where we have to find a way to solve conflicts in a productive way. Once we make those decisions, it should be easy in a way.
And if I may add, we also have two societies, the ISCS and ESIAC, that can help also framing an ongoing work, and that can help giving a frame to us this effort on the long term. There is within ESIAC there is the Scientific and Technical Committee, the STC. So this could be this will not help the technical issue of the programming language, but this could be this could give a framework also to share and to organize this this shared work, this open work.
I have two more polls while we're discussing this. One is just Clara would like to know what everyone's favorite programming language is. So we'll go ahead and launch that one while we're discussing. And the other one is talking about who wants to help. Ing, do you have any thoughts on what we've discussed today while this poll is going on?
Yeah, for the model, I also have a question. When you make it become open source, like for some, because for example, like we have different kind of emission sources. So when people try to simulate emission from one kind of sources, how like when we have this open source, people have this programming and they can link in with the whole core, and then how we validate those, like how we control the quality of the whole thing works. That's also I have this question. And regarding for this framework, I think there's still a lot of work for our researcher to do, like some key parameters. I think to make this this model finally work, key parameters are very important, and how can we develop the good method to collect those key parameters experimentally and make people to use this can use this framework, and from like when they select the key parameters from the kind of the database, I think that can help to make this whole model framework work. And then and there's also like other considerations regarding for this model framework, like the environmental scenario. We can build in more environmental scenario, how people behavior and then the use customs can influence their exposure, and then how about the accessibility and bioavailability kind of link with the exposure. So those are kind of like a work like for us, of our researcher to do, and that's kind of my thought and also my questions. Thanks.
Okay, so we're wrapping up on an hour now. So, you know, it looked like R was slightly favored over Python for those who actually cared if we wanted to do it purely within a non-commercial, well, non-specific package. And now we're asking if you're interested in, you know, taking the next step with us and really getting over that first hurdle of getting together, meeting and figuring out, you know, how should we do these parameters. And this question is not anonymous, so I can actually go back and figure out your name if you said yes. So hopefully you hit the right button, and we'll hopefully use this as a launch pad for, you know, where we're going to take our next step. And, you know, hopefully we'll probably, if we get enough interest in this, we can have a session where we actually start laying out the fundamentals of how we do this, how we set up a, you know, group to figure out software packages, naming conventions, handshake parameters, and all that kind of stuff. Because I think once we get over that first initial hurdle and set that up, I think we really can start developing a community and have it be truly community driven. So of those, we still have 65 people who haven't said yes or no. So I'm going to keep this poll open. But so far we have 45 people who are interested in, you know, being part of this community. And so I think what we'll do from this point is hopefully we'll have another international meeting as part of either Healthy Buildings Europe or Healthy Buildings America, or both, and move forward to get a group together to actually start answering the fundamental questions of now that we say yes, we want to do it, to actually figure out how to do it. So at this point, I'd just like to thank the panelists, thank the people who asked questions. I'm sorry we weren't able to answer everybody's questions, address everybody's questions, and hopefully look forward to seeing you in the future and making this truly a global community to answer these, to come up with a really powerful tool to model how we can deal with indoor exposures to SVOC and VOC emissions. Thank you.
Thank you, Dustin, for facilitating so well.
Yeah, thank you.
Thanks, Dustin.
Thanks.
Thank you.
Here's the results. Thank you.
All right.
Nice.